Now, let's talk about IP addressing. So what I'm gonna do is I'm gonna add an IP address. Okay, this is probably the most common IP address with a prefix. Prefix is the /24. We're gonna talk about what's this prefix for later, but I believe this is the most commonly used IP address. Now, IP address consists of two parts. One is the network and one is the host. Now, before we jump into details, I would like to highlight that the IP address is a total of 32 bits, and I will call this group. For every group, it has a total of 8 bits. That's why we call these octets. So this is 8-bit, 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 8-bit. 8 times 4, total of 32. So 32 bits all in all. Now, what I'm gonna do is I will talk about the network side and the host side. Again, we have two parts for the IP address, and I'm gonna use a different color for the network part. So this is the network part, okay? And I'm also gonna use a different color for the host part. So the network would be 192.168.1, okay? That is the network, and the host part is the last one here. And maybe you're thinking, how do you know which one is the network and which one is the host? Well, I'm gonna add here a divider, and if you think about it, the reason why we add the divider here because this is the network, consists of 3 octets. Okay, 192, 168, and 1. Those are 3 octets. And the reason we can identify that these are the network is because of this prefix value /24. So basically, the /24, this represent the part of the network, and everything that is the difference between 32 and this 24 is the host side. Okay, so 32 minus 24, the total of 8, which is this 8. Okay, so that is the host side. Okay, 8-bit only for the host side. Now, if let's add here network, and this is the host. Okay, and this is the prefix. We're gonna talk about more on prefix later, but what I would like to talk about first is our topology. Remember, we had the topology where we have a switch, and our switch is connected to PCA. What else? Connected also to PCB, server C, and server D. Okay, this is our topology. Take note that we have, or we are using 192.168.1.1, 192.168.1.2 for PCA and PCB. And for the server C and server D, what we used are 192.168.1.3 and 192.168.1.4. If you think about it, these 4 hosts are using the same network. Okay, that's why they can communicate to each other. So PCA can send traffic to PCB. It can also send traffic to server C, server D, and even server C can send traffic to server D. All hosts, okay, in the network. They're also a part of the same broadcast domain. Okay, we're going to talk about broadcast in a bit. So what we used in our previous example, in our previous whiteboard, is this network 192.168.1. Okay, and we just changed the last octet, .1, .2, .3, and .4. Now, what if server D is not using the same network? Let's say server D is using 192.168, let's say 2.4. Can PCA send traffic to server D? The answer is absolutely not. It's not possible, because server D is a different network, and we have a dedicated device to be able to send from one network to the other. We're going to talk about that later. Now, let's dissect the IP addressing. And we're still gonna use the 192.168.1.0. I'm gonna use 1.0, okay? And all of it, actually, it's not just 1.0. I'm gonna use 1.1. I'm gonna specify the range of IP address for this network. So we're using .1, .2, 192.168, 1.3, and if I continue, this will end until 192.168.1.255. Why 1.255? Because an 8-bit has a maximum value of 255. Now maybe you're thinking, so what's the point? Well, here's the point. First, I would like to also specify that this is divided, okay? We know that these are the network side, and this, excuse me, it should be below. These are the network side, and this is the host side, okay? .0, .1, .3, and .255, okay? Now, if you think about it, or maybe you're wondering how many IP address in this specific network, the /24 network. Well, the total IP address is actually equivalent to 256. Why? Because it ends 255, but it started with 0, so a total of 256. Now, it's not yet the total number of usable IP address, okay? It's not 256 because we need to subtract 2, okay? So we need to subtract 256 minus 2. That's where we get the total usable IP address, which is 254. This is our final value. And maybe you're thinking, why do we need to subtract 2? The reason why is 2 of these IP addresses are special. You cannot use it in an interface, okay? You cannot configure it in your ports. These IP addresses are this IP address and this IP address, okay? This is the network. And this is the broadcast. So think of this as special IP address, and they're unusable. Now, to put it in perspective, remember in our previous discussion where the switch has to send broadcast to all active ports in order to learn the destination IP address, which is 192.168.1.2. Now, think of the broadcast IP address is the one, the broadcast will, once it triggers, it will use this broadcast IP address. So in short, the broadcast process will not work without this special IP address, which is 192.168.1.255. Okay, so again, it requires broadcast IP address. Now for the network, here's how it works. You see, this is the IP address that we use in our interface. Okay, interface configuration 192.168.1.1.1. Excuse me, 192.168.1.1. So this is the interface configuration. But what you will see in the routing table is not 192.168.1.1. You will actually see the network 192.168.1.0/24.